Hi friends, welcome to our YouTube channel Knowledge Academy. The main aim of this lecture is to discuss about the UPSC Civil Service main questions of the signal systems in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel and don't forget to press the bell icon button. So whenever we upload a new video, the direct notification comes on mobile. If any improvements in our video lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. So why do we waste more time? So let's get started. So now we are going to solve the 11th question. See the question here. A system has the impulse response h of t is equal to e to the power of minus t. So what would be the response if the system is excited by a unit step function delayed by t seconds? So in this question they are given the impulse response of a LTI system and also they are given the input as some delayed function of the unit step function by t seconds. So now we need to find what is the response of this system, and this question is given in the IAS 2008 for 6 marks. So let's solve this numerical. So in the question they are given for this LTI system the impulse response is h of t is equal to e to the power of minus t, and also they are given the input x of t is equal to, it is a sum of the delayed function of the t by t seconds, capital T seconds. So therefore x of t is equal to u into t minus t. So now we have to find what is the response of this system. As for any LTI system, if the input is x of t and the impulse response of the system is h of t, then the output will be convolution of the input and the impulse response. So therefore y of t is equal to x of t convolution of h of t, because the convolution is going to satisfy the commutative property. So therefore we can replace both the or interchange these two things. So therefore h of t convolution of the x of t. So now I am going to use this one, h of t convolution of x of t. So therefore the formula is integration tau is equal to minus infinity plus infinity h of tau x of t minus tau d tau. So therefore here h of t is e to the power of minus t, but we need h of tau. So therefore in place of t, replace t by tau. So therefore h of tau is called e to the power of minus tau. And similarly x of t minus tau, but we know the value of x of t which is u of t minus tau, but we need to find what is the x of t minus tau. So therefore in place of t, replace t by t minus tau. So therefore u of t minus tau minus capital T. So therefore this is the things we are going to get. So now I need to draw this graph u of t minus tau minus t, then only I can know what are the accurate limits. This is the general limits which is tau is equal to minus infinity plus infinity. So now with the help of this function, now I am going to redefine the limits. So first thing is, in order to draw this one, we need to know what is the u of tau. So u of tau is nothing but it is going to exist from t is equal to 0 to infinity, and at t less than, means at tau less than 0 its value is 0, but at tau greater than 0 its value is 1. So this is the thing for u of t. So now I want to draw what is the graph for the u of t minus tau minus capital T. So here the variable is tau. So therefore I am going to replace or interchange in this manner also. Means I can write in this manner also, which is u of minus tau minus of t minus t. So therefore now you see here for this one, for this u of tau, the initial value is 0 and the final value is infinity. Means here this graph is going to exist from t is equal to 0 to infinity. So 0 to infinity. See, I have written this is in the standard form, which is u of minus tau minus of t minus tau, capital T minus t, to this initial and the final position. So therefore I am going to get t minus t, and infinity place if you add anything, again it is equal to infinity. So again there is a minus, so therefore you have to divide by minus. So therefore if you divide this by minus, you are going to get t minus capital T, and if you divide by minus 1, you are going to get minus infinity. So therefore now for this graph, the initial point will be at t minus capital T and the final point will be at minus infinity. So this graph is going to exist from initial point to the final point. So therefore t minus capital T to minus infinity, and its value is 1. So if you see carefully, this has a value of 1 from minus infinity to t minus capital T, and after that its value is 0. So therefore now instead of doing this integration from tau is equal to minus infinity to plus infinity, because here this function is exist only from minus infinity to t minus tau, and after that it is 0. So therefore now I am going to change these limits from tau is equal to minus infinity to t minus t, because in these limits only this function is defined, and after that this function is 0. So therefore I am going to, this value is 1 in this limit, so therefore into 1. So e to the power of minus tau into 1 is nothing but e to the power of minus tau d tau. So now I am going to do the integration with respect to tau. So therefore this is nothing but e to the power of minus tau by minus 1, and the limits are tau is equal to minus infinity to small t minus capital T. So now I am going to substitute the upper limit minus the lower limit, and this is the things I am going to get. So finally I am going to take minus inside, so therefore this is the thing finally I am going to get, and this is the equation for the y of t from minus infinity to plus infinity. And if you see carefully here, there is a plus e to the power of infinity. No matter whatever the thing you are subtracting or adding to e to the power of infinity, the answer will be always infinity, means the response will be always unbounded, means there is no particular finite value. Always for any value of time lying between the minus infinity to plus infinity, the y of t is going to have always a infinite value, means it is an unbounded response. So we can conclude that y of t is equal to infinity for any value of t which is lying between the minus infinity to plus infinity. So finally we are going to conclude that the response is an unbounded response, means it is always equal to infinity for any value of time for minus infinity to plus infinity. So finally the solution of this question is nothing but the output is a unbounded response. So now we are going to solve the 12th question. See the question here. What are the energy and the power signals? So what are the energy and the power signals? Compute the energy and the power contents of the following signals and indicate whether they are energy or power signals. So in the question they are given the two signals, which are the xt of n and the yt of n, and we need to find whether these are the energy signals or the power signals. If they are energy signals, we need to find their respective energy, and if it is a power signal, means we need to find the respective power. And also we need to define what is the energy and the power signals. So this question is given in the IAS 2003 for the 6 marks. So let's solve this numerical. So in the question they asked us to define what is the energy signal and also the power signal. So basically what is the energy signal is nothing but these are the signals which are going to have the finite energy for over the time period, means for all over the time, means from minus infinity to plus infinity, the energy of the signal is going to have a finite value, but the power is defined as the energy by time. As the energy is a finite value, but the time is from minus infinity to plus infinity, so therefore the time period will be infinite, but the energy is a finite value. By finite value, by anything infinite is nothing but 0. So therefore these are the signals which are going to have the finite energy for over the, means for all over the time, and also the power is 0 for these signals. And these signals will going to have the signals are absolutely summable and also the absolutely integrable. So for discrete time signals, the energy is defined as summation n is equal to minus infinity plus infinity mod of x of n whole square. So this formula is used for the both real signals and also complex signals, because we are going to use the modulus of the x of n. And similarly for the continuous time signals, energy is defined as a integration t is equal to minus infinity to plus infinity mod of x of t whole square dt. So it is nothing but this is used for both complex signals and also the real signals, because we are going to use the mod. So this is for the discrete time signals and it is for the continuous time signals. See, whenever this energy is absolutely summable for discrete time signals and whenever the energy is absolutely integrable for the continuous time signals, then only we are going to get a finite value. So therefore whenever the energy is a finite value or the power is 0, then only we are going to say these signals is said to be energy signals. So finally what I am trying to say is the signals which are going to have a finite energy for all time period from minus infinity to plus infinity and the power is 0, and these signals are absolutely summable and also the absolutely integrable, then only these signals are said to be the energy signals. So now what is the meaning of the power signal? And these are the signals which are going to have the energy is equal to infinity for all time, and the power is going to get the finite value, because see, the power is defined as the energy per time. As the energy is infinite and the time is also infinite, so therefore as infinite by infinite we are going to get some finite value. So therefore this is the power expression for the discrete time, for the continuous time signal, which is limit t tends to infinity integration minus t by 2 to plus t by 2 mod of x of t whole square dt by t. As we are going to use the mod, so therefore this formula is used for the both complex and also the real signals of continuous time domain. And similarly for the discrete time signals, the power is defined as the p is equal to limit n tends to infinity sigma n is equal to minus n to plus n mod of x of n whole square by 2n plus 1, and this is for the discrete time signals of complex and also real value. So therefore now if you see carefully here, the energy is infinite means these are not absolutely summable and also not absolutely integrable, because we are going to get energy is equal to infinite means these are not absolutely not summable and also absolutely not integrable. So finally what I am trying to say, these are the signals which are going to have the energy is equal to infinite for all time from minus infinity to plus infinity, and also the power is equal to finite value, and we can easily say that these signals are absolutely not summable and absolutely not integral because energy is equal to infinite. So this is the pure definitions of the energy signals and also the power signals. So you have to write the definition and also these two formulas, and also this definition and also these two formulas. So this is the first signal they are given in the question, which is x of n is equal to minus 0.5 all to the power of n u of n. So now we need to find whether this signal is an energy signal or power signal. If it is an energy signal, we need to find what is its energy, and if it's a power signal means we need to find what is its power. So let me draw what is the diagram for this x of n, because it's a u of n means for n less than 0 its value is 0, for n greater than 0 we need to find what is its values. So when n is equal to 0, anything by 0 is again 1, and if n is equal to 1 we are going to get minus 0.5, and if n is equal to 2 we are going to get minus 0.5 whole square is again it's a positive value. So therefore if you see carefully, this is a decaying signal because 0.5 whole square, 0.5 whole cube, it is nothing but sometimes positive and negative, but it's a decaying value means the signal is going to decay. So therefore now let me find out what is the energy. This is a discrete time signal because it is when at only some discrete value of the time signals. So now what is the energy? Energy for any discrete time signal is sigma n is equal to minus infinity to plus infinity mod of x of n whole square, and this formula is for both complex signals and also real value signals because we are going to use the mod of this one. And if you see carefully, this is a real signal because there is no imaginary part in this x of n, so we can say this is a real signal. So whenever there is imaginary term in any signal, then we can say that signal is said to be a complex signal, but here there is no imaginary part in the signal, so we can conclude this is a real signal. So therefore here in place of mod of x of n, which is minus 0.5 all to the power of n u of n, substituting there and square. So therefore now I am going to define the limits because u of n is going to present from only 0 to infinity but not from minus infinity to 0. So therefore now I am going to make this limits to say n is equal to 0 to infinity minus 0.5 all to the power of n whole square. So a to the power of m all to the power of b means a to the power of m all to the power of n is nothing but a to the power of m into n. So therefore now this 2 into n. So therefore now 2 into n, and similarly we can write in another fashion also, which is a to the power of n all to the power of m. So both are same. So a to the power of m all to the power of n is equal to a to the power of m into n, and similarly a to the power of n all to the power of m is nothing but again a to the power of m into n. So same thing I am going to do now here, 2 and all to the power of n. So minus 0.5 whole square is nothing but minus 0.5 is nothing but minus half whole square is again 1 by 4 because it is always a positive value because we are going to do square. So sigma n is equal to 0 to infinity 1 by 4 all to the power of n. Now when n is equal to 0 and n is equal to 1, at n is equal to I am going to substitute here. So I am going to get 1 plus 1 by 4 square up to infinity means we are going to get it like this values. So if you see carefully here, you know the basic formula of GP series, which is a plus ar square up to anything is equal to a by 1 minus r. This is the only formula for mod r less than 1 means the ratio, this r part, the magnitude of this value has to be less than 1, then only this whole series is going to converge to a finite value which is a by 1 minus r. So the a value is the initial value and r is the how much ratio it is going to increase. So therefore here a is equal to 1 and r is equal to 1 by 4. So if we substitute here a by 1 minus r, a is 1 and r is 1 by 4. So finally we are going to get energy is equal to 4 by 3, which is a finite value. So therefore whenever the energy is a finite value, the power is nothing but energy by time. So energy is a finite value, but you can see carefully whenever the energy is a finite but the time is a infinite. So therefore finite by anything infinite is nothing but again a 0. So therefore power is equal to 0. So from this we can conclude that as the energy of the signal having a finite value but the power is equal to 0, so we can conclude that this signal is said to be a energy signal. So finally one small point is here, whenever any signal which is decreasing or whether it is decaying, then the signal by default it is said to be a energy signal and it is not a power signal, because energy is going to have a finite value, so therefore the power of the signal will be 0. So finally this signal is said to be a energy signal of energy value 4/3 units. So in the question they are given the another signal which is x of n. In the question they are given y of n, but I am going to take here x of n for the convention. So x of n is equal to 2 into e to the power of 3j n u of n. And if you see carefully, there is a j term. J is nothing but a complex term. So if any signal there is a j term means a complex, then we can say the signal is said to be a complex signal. So therefore now I am going to define, because there is a u of n, the signal is going to define from only n is equal to 0 to infinity. So now I want to see what is the value of at 0. So x of 0 is equal to 2. In place of n substitute here 0. So we are going to get 2. And whatever I want to know what is the value of at x is equal to 1. So therefore at n is equal to 1. So in place of n substitute 1. So 2 into e to the power of 3j. So e to the power of j theta, it is nothing but cos theta plus j sin theta. So in place of theta, which is 3. So therefore 2 into cos 3 plus j sin 3. So it is going to have some real value and also complex value. So therefore we can say again this signal is said to be a complex signal. So similarly x of 2 is nothing but when substitute n is equal to 2. So we are going to get 2 into e to the power of 6j, which is 2 into cos 6 plus j sin 6. So up to infinity we are going to get terms like this. So now I want to know whether this signal is an energy signal or a power signal. So now what is the energy? The energy definition is E is equal to sigma n is equal to minus infinity to plus infinity mod of x of n whole square. And this is the formula for both real signal and also the complex signal. So here this is a complex signal. So we need to find only the magnitude. What is the magnitude of this one? So magnitude of x of n, it is nothing but say the magnitude of 2 into e to the power of 3j n. So but here if you see this is the 2 is nothing but a scalar quantity, so it can come outside. So 2 mod of e to the power of 3j n. So e to the power of j theta, so the magnitude of e to the power of 3j theta is equal to 1, because e to the power of j theta is equal to cos theta plus j sin theta. So if you want to know what is the magnitude, e to the power of j theta, magnitude means root over cos square theta plus sin square theta. So cos square plus sin square is nothing but 1. So root over 1 is equal to 1. See, the magnitude value is equal to 1. Simply we can write in another fashion also, e to the power of j theta is equal to 1. 1 at an angle of tan of sin theta by cos theta. You can write in this manner also, e to the power of j theta is equal to 1 at an angle of theta. So therefore the magnitude value is 1 and the angle value is theta. You can write in this manner also. So therefore e to the power of j theta magnitude value is 1. So therefore now here, so mod of x of n is nothing but here 2 and this is value is 1. So therefore 2 whole square is nothing but this is a 2 whole square, because the magnitude of e to the power of 3j n is nothing but 1. So therefore this total value will become 2. So 2 whole square is again 4. So 2 whole square is 4. Now I am going to take here, this is a limit, right? So we are going to add from minus infinity to plus infinity. So we are going to add from minus infinity to plus infinity is nothing but we are going to add 4 this many number of times, which is 4 plus 4 plus 4 plus up to infinity times is nothing but 4 into infinity. So value will become infinity. So therefore we can say the energy of this signal is an infinite value, which is infinite. And similarly now I want to know what is the power of this signal. Power is equal to limit n tends to infinity, sigma n is equal to minus n to plus n mod of x of n whole square by 2n plus 1. So here same thing, the mod of x of n value we know, which is 2. So therefore 2. So but there is a square, so now 2 square I am going to take it, because the limit here n is equal to minus n, but u of n is defined from only n is equal to 0. So therefore this limit is going to converge to sigma n is equal to 0 to plus n. So and finally this 2 square is going to come outside. See, I am going to add this 4 for n is equal to 0 to plus n, means 0, 1, 2, 3 up to n, means total terms are n plus 1. So therefore 4 into n plus 1, and similarly here 2n plus 1. Now I am going to take here n as a common, which is 1 plus 1 by n, and here 2 plus 1 by n, because n is going to get cancelled. So I can write in this manner also, 4 into 1 plus 1 by n by 2 plus 1 by n. And here n common means they both get cancelled. Now I want to substitute n is equal to infinity. So 1 by infinity is again 0 and 1 by infinity is 0. So here in the upper part we are going to get 4 and the down part we are going to get 2. So 4 by 2 is equal to 2. So we are going to get power is equal to 2 units. So power is equal to 2 units and energy is equal to infinite units. Means this signal is said to be a power signal, because energy is an infinite value and the power is a finite value. So here if you see carefully, this signal is going to have a same means here the magnitude of this signal is always 2. it is always 2, it is not going to decay or it is not increasing, means it is going to have a constant value. Again, if you do the summation for a constant value is again infinity. So therefore we can conclude that this signal is either not decreasing or increasing, but it is having some constant magnitude value. So whenever the signal has a constant magnitude value or whether it is an increasing signal, always the energy will be infinite. So directly what I am trying to say is, whenever the signal is not decaying, means the energy is infinite. So therefore energy is infinite. So by default this signal is said to be power signal. So the A part is a energy signal and the B part of the signal is nothing but a power signal. So now we are going to solve the 13th question. So the question here, sketch the following function and find its Laplace transform. So f of t is equal to r of t minus r of t minus 3, where r of t is a unit ramp function. So here now in this question they are given some function f of t is equal to r of t minus 3, where r of t is nothing but a unit ramp function. So now we need to draw this diagram for this function f of t, and also we need to find what is the Laplace transform of this signal f of t. And this question is given in the IAS 2010 for 5 marks. So let's solve this numerical. So in the question they are given the function f of t is equal to r of t minus 3. So r of t is nothing but a unit ramp function. See here, for r of t in front of this there is a coefficient 1, and similarly for r of t minus 3 the coefficient in front of r of t minus 3 is nothing but minus 1. So for r of t the coefficient is 1 and r of t minus 3 the coefficient is minus 1. So for any ramp signals you have to consider only the coefficients. These coefficients are nothing but the slopes of this signal, and similarly the plus 1 means here the slope of this r of t is plus 1, and for r of t minus 3 the coefficient is minus 1. So therefore its slope will be minus 1. So in another term means you can write this r of t, this function f of t in terms of u of t also, because r of t is equal to t into u of t. So therefore for r of t substitute t into u of t, but r of t minus 3, so in place of t substitute t minus 3, which is t minus 3 into u of t minus 3. So here f of t is written in terms of r of t, and here same thing, this function f of t is also written in terms of the unit step signals. So finally now I need to draw this function f of t. So here the basic idea is here. So always the first r of t has a slope 1, and for r of t minus 3 the slope is minus 1. So how to draw this diagram is simply, see here, because r of t is going to exist. So basically r of t, this is r of t. So for this is a signal r of t, it is going to have just 0, and from here this is a time t. So this r of t is equal to t into u of t. So therefore this is a, suppose its value is 1 means it is also value 1. So like this it will be there. This is r of t. But now I want to draw this function f of t. So see carefully here. This is the signal t. So this is the f of t. So now same thing here, because r of t is going to exist from only 0, but at t less than 0 its value is 0. So for the f of t also this r of t will be same thing from 0. So it will be like this straight line. See, but at t is equal to 3, so r of t minus 3 is nothing but this signal is going to exist from t is equal to 3. So up to 3. So up to 0 to 3 its value will be a straight line, means at t. So its value is 1 means 1, 2 means 2, 3 means 3. So at up to 3 nothing is going to happen. So therefore like this it is straight line. So here also it is 3. But at t is equal to 3 this signal is also going to exist. So up to 0 to 3 only this r of t, this f of t is nothing but r of t. But at t greater than 3, so what is going to happen, this r of t minus 3 is also going to exist. So now what I am going to do, so the slope is minus 1, right? So this line slope is 1, because 3 by 3 slope is 1. So this slope is nothing but plus 1. So now I need to add a slope of minus 1. So from here I need to add a slope of minus 1. So initial slope is plus 1, and now I need to add a slope of minus 1. So therefore plus 1 and minus 1 is going to become now 0. Plus 1 and minus 1 will become 0. So therefore it will be a straight line. Straight line has a slope is how much? The straight line slope is 0. So therefore this is a straight line you have to draw. So for this initial from 0 to 3 the slope is plus 1. From 3 to infinity, because of two slopes, plus 1 and minus 1, because at t is equal to minus 3 the coefficient is minus 1. So we have to add the another slope minus 1, and the initial slope is plus 1. So plus 1 minus 1 is again slope 0. So therefore this slope is 0. So this is the way you have to draw the diagram. So finally this is the function f of t. So therefore this is the diagram of the function f of t, which is r of t minus r of t minus 3. Now you have to find what is the Laplace transform of the signal f of t. So the relation is f of s is equal to integration t is equal to minus infinity to plus infinity f of t e to the power of minus st into dt. And if you see carefully, this f of t is going defined from only 0 to infinity. At minus infinity to 0 this function is 0. So therefore now See again, this function f of t is going to have from 0 to 3 its values one thing, and from 3 to infinity its values 3. So from 0 to 3 this is nothing but a t, because from 0 to 3 only f of t is equal to t, because this is not going to exist. So therefore f of t is equal to only t, means r of t is nothing but t into u of t. So therefore f of t is equal to t into u of t. So I can write here. So therefore f of t is equal to t into u of t for 0 less than or equal to t less than or equal to 3, but it is equal to 3 for t greater than or equal to 3. So now I am going to use this one. So therefore integration t is equal to 0 to 3 one function, and from 3 to infinity another function. So from f of t for 0 to 3 its value is t, and similarly f of t is equal to from 3 to infinity its value is 3. So now I am going to substitute these values, and now I need to do the integration of t into e to the power of minus st. So the basic formula is nothing but integration of f into g. So suppose if you are going to multiply two signals, and if you want to know what is the integration, then the basic formula is f into integration of g minus f dash of double integration of g plus of f double derivative and triple integration of g, and it just goes on, means plus minus plus minus plus minus. So therefore now here you have to choose this eilate. Eilate is nothing but this is inverse functions, logarithmic functions, algebraic functions, and this is trigonometric functions, and here is the exponential functions. So whatever the function is coming in this rule, it has to be f, the other thing will be g. So if you see carefully, here t is nothing but algebraic, and e to the power of minus st is nothing but exponential. So therefore you see algebraic is going to come first and then the exponential. So whatever the function which is going to come first, you have to take it as a f, and the remaining thing was to be g. So here algebraic is f and g is nothing but exponential. So you have to use this formula. So by using this formula, now I am going to do this one. So f is t, and you have to do the integration e to the power of minus st by minus s. Again minus, here t dot means we have to do the differentiation of t dash is nothing but 1, and you have to do again this one integration again. So therefore e to the power of minus st by s square, and you have to use the limits 0 to 3. So here this is nothing but a constant, so you can take constant outside and do the integration for this only one function. So e to the power of minus st by minus s from t is equal to 3 to infinity. So now what I am going to do is substitute the limits at t is equal to 3 and minus of t is equal to 0, and similarly substitute t is equal to infinity minus of t is equal to 3. So substitute the upper limit minus lower limit, and finally after doing the simplifications we are going to get f of s is equal to 1 minus e to the power of minus 3s by s square. And I recommend you to do this calculation and do it in a very careful manner. So finally you are going to get the result f of s is equal to 1 minus e to the power of minus 3s by s square. So therefore for this graph f of t function, the Laplace transform is nothing but 1 minus e to the power of minus 3s by s square, and this is the correct solution of this question. So you have to solve in this manner in any competitive examination. Now we are going to solve the 14th question. See the question here. A system consists of two blocks connected in cascade. The first block has impulse response h1 of t is equal to 2 into u of t. The second block is shown below. So this is the second block, which is inductor and a resistor, input and output. So now find the impulse response of the overall system using the relation h of t is equal to h1 of t calculation of the h2 of t. So in the question they are given that the first block has an impulse response which is 2 into u of t, and the second block they are given the diagram. So now we need to find what is the, when these two systems are connected in cascade, so now we need to find what is the total impulse response, which is the convolution of the first system impulse response and the convolution of the second system impulse response. So now this question is given in the IAS 2012 for 20 marks. So let's solve this numerical. So now in the question they are given the first LTI system has an impulse response h1 of t is equal to 2 into u of t, and this is the second system. This is the second block diagram. So this is a resistor and inductor. So input and this is the output. So now I am going to convert into Laplace domain. So in the Laplace domain R will be same R, and the L will be SL. This is Vi of S, and this is the V naught of S. So now I want to know what is the transfer function of this one, means the output by input. So output by input is nothing but here by using the voltage division, which is this resistor by the total impedance R by SL plus R. So this is called as a transfer function of this second system. So h2 of s is equal to R by, so now I am going to take here L as a common. So L into S plus R by L. So L is going to come, which is R by L into S plus R by L. So now what I am going to do is, now I am going to do the Laplace inverse. So I want to know what is the time domain expression for this H2 of S, which is H2 of T. See, for any transfer function, the impulse, the Laplace inverse of any transfer function is nothing but its impulse response. So therefore H2 of T is equal to, so now for this one, this constant R by L into e to the power of minus R by L T into U of T. This is called as a Laplace inverse for this H2 of S. The basic formula is, when f of t is equal to e to the power of minus 8 into U of t, the Laplace transform is 1 by S plus A. So this is nothing but some constant by S plus A. So here A is R by L. So therefore e to the power of minus 8 into U of t, which is e to the power of minus R by L into t. So by using this relation, we are going to do from Laplace inverse. So this is called as the impulse response of this system. So for this system, this is called as the impulse response. So these two are connected in the cascade fashion. This is the first LTI system impulse response, and this is the second system impulse response, and this is the input and output. So whenever you are going to do the cascading, it is equivalent to, means this total circuit is equivalent to one circuit, which is one LTI system of impulse response. H of t is equal to convolution of this two LTI systems impulse response, which is H1 of t into convolution of H2 of t. So we know the value of H1 of t. The first system LTI system impulse response is 2 into U of t, and the second system LTI response is R by L into e to the power of minus R by L into t U of t. So we know the H1 of t and H2 of t, and we need to find what is the H of t. This is the thing we need to find now. So the basic convolution relation, H1 of t convolution of H2 of t is nothing but tau is equal to minus infinity plus infinity. This is a standard equation, which is H1 of tau into H2 of t minus tau d tau. So this is the H1 of t. So in place of t, substitute tau. So this is the thing we are going to get. And similarly H2 of t minus tau. But we know the value of H2 of t. So but we need H2 of t minus tau. So replace t by t minus tau. So wherever t is there, you have to substitute t minus tau. So this is the thing we are going to get. And the terms which I am going to take here, 2 R by L e to the power of minus R by L into t minus tau, and this U of tau into U of t minus tau. I have written in this fashion. And if you see carefully, now I need to redefine the limits based on this U of t and U of t minus tau. So then only I am going to get the further results. So now I will draw what is the diagram or overlap regions for this U of tau and the U of t minus tau. So now I wrote the same expression again. So now based in this U of tau and U of t minus tau ranges, I need to redefine these limits. So now I want to draw the diagrams of this U of tau and U of t minus tau. So U of tau is nothing but it is going to exist from t is equal to 0 to infinity with a value of 1, and t less than 0, its value is 0. So now I want to draw what is the diagram for this U of t minus tau. So therefore this x-axis is nothing but 2. So therefore U of t minus tau I can write in another fashion, which is U of minus tau minus of minus t. So now I wrote in a standard form. So now here for this U of tau, the initial is 0 and the final position is infinity, means in the x-axis 0 to infinity. So now U of minus tau minus of minus t is nothing but you have to add the minus t to the initial and the final positions. So now I am going to add the minus 2 minus t to the initial and the final position. So 0 minus t is nothing but minus t, and infinity minus t. So you separate any small quantity from infinity, still it is an infinity. Again there is a minus. Minus means you have to divide by minus 1. So therefore minus t by minus 1 is again t, and plus infinity by minus 1 is nothing but minus infinity. So therefore now this graph is going to have initial position at t and the final position at minus infinity. So therefore this is the t. Let me assume this is t and this is minus infinity. So therefore like this the graph will be with a value of peak value of 1. So now what I am going to do, now I am going to multiply these two signals. Now I am going to multiply these two signals because U of tau into U of t minus tau. So based on this only I need to redefine these ranges. Suppose when t is less than 0 means, when t is less than 0 means this signal is at from here. So then this is going to exist from above 0 and this is going to exist below 0. So therefore there is no common overlap region. So whenever there is no common overlap region means overall multiplication will become 0. So therefore here when t less than or equal to 0, what is going to happen? There is no overlap region between the U of tau and the U of t minus tau. So therefore the H of t will be equal to 0. So for when t greater than or equal to 0, yes, from 0 to t there is a value of 1. and from tau greater than t, this is a 0 but this is some non-zero, so 1 into again 0 is 0. Similarly for tau less than 0, here it is a value of 1 but here it's a value of 0. 0 into 1 again 0. So finally what I am trying to say is nothing but here for t greater than 0, the limit is going to exist from only 0 to t, because for remaining other regions, one is 0 and the other is 1. So overall product will be again 0. So finally, for t, when t greater than or equal to 0, we are going to get the overlap region for 0 to tau. Means tau can vary from 0 to tau, t only. So therefore, for t greater than or equal to 0, h of t, this total limit is going to converge to tau is equal to 0 to t. So same thing again I have written. So this 1 into 1, both are 1 in this region. So 1 into 1 is again 1. So same thing I have written it again here. So now what I am going to do, I need to do this integration for this one. See here, I am going to do integration with respect to tau. So therefore, t is said to be a constant because I am going to do only with respect to tau. So remaining other variables will be treated as a constant. So t has to be treated as a constant. So I have written it like this also. So 2 into r by l e to the power of minus rl by t, integration tau is equal to 0 to t e to the power of r by l tau into d tau. In this fashion also I have written. So now I need to do integration for this signal. So integration of e to the power of at is nothing but e to the power of at by a. So therefore by using that formula I have written here. Now I need to substitute t and 0. In place of tau, substitute t, again minus of 0. So same thing. Then if I substitute t, I am going to get here 1 by r by l e to the power of rl by t minus tau. In place of tau, substitute 0 means nothing but 1. So therefore this r by l get cancels. So 2 into e to the power of minus rt by l into, this is the equation. Now I am going to take this 2 into e to the power of minus rt by l into inside. So therefore this get cancels. So finally I am going to get 2 minus 2 into e to the power of minus rt by l. So now I am going to take 2 as a common. So therefore 2 into 1 minus e to the power of minus rt by l. This is the expression of the h of t for t greater than or equal to 0. So for t less than or equal to 0, the h of t value is 0, and for t greater than or equal to 0, h of t value is 2 into 1 minus e to the power of minus rt by l. So simply I can write in this fashion. So h of t is equal to 2 into 1 minus e to the power of minus rt by l into u of t. So this self defines that for t less than 0, h of t is equal to 0, and for t greater than 1, the h of t is equal to 2 into 1 minus e to the power of minus rt by l. So finally this is the impulse response of this overall system. So now we are going to solve the last question of this lecture. See the question here. A system input x of t, output y of t, as is described by the relation d square y by dt square plus 8 into dy by dt plus ky is equal to 50 into x of t. Evaluate the response y of t and its maximum value for an input x of t is equal to 2.5 u of t, where u of t is a unit step function given that k is equal to 25. See, in this question they are given the input is x of t and the output is y of t. They are also given the relation between the input and output by some differential equation, and also they are given the input value x of t is equal to 2.5 into u of t, and also they are given the k is equal to 25. So at these values we need to find what is the response of this function, means y of t time domain expression we need to figure out, and also we need to find what is the maximum value of this function. So if you plot this y of t, then at some particular value of t we are going to get a maximum value of this function y of t. So that y max also we need to figure out. So this question is given in the IS 2015 for 10 marks. So let's solve this numerical. So basically in the question they are given the input output relation with respect to the input and output is d square y by dt square plus 8 into dy by dt plus ky is equal to 50 into x of t, and also they are given the input x of t is equal to 2.5 into u of t, and also they are given the for a value of k which is 25, we need to find what is the output response, means y of t, and also we need to find what is the maximum value of this y of t also we need to figure out. So now I am going to substitute k is equal to 25 and also x of t is equal to 2.5 into u of t. So finally what I am going to get in this manner. So after substituting k is equal to 25 and x of t is equal to 2.5 into u of t in this equation, this is the equation I am going to get. So now this equation I need to solve in order to get the response y of t I need to get here. So here in this question they have not given any initial values of the y of t. So in this question they have not given any initial values. So now I am going to assume that now I am going to do the Laplace transform. So in the Laplace transform here the initial conditions are not given, means I am going to assume the system is at initially at rest, means the initial conditions are all 0. So therefore now I am going to take the Laplace transform. So after taking the Laplace transform, now I am going to get s square into y of s plus 8s into y of s plus 25 into y of s is equal to u of t means 1 by s. So therefore 125 by s. So after rearranging this one, finally I am going to get y of s is equal to 125 by s into s square plus 8s plus 25. See, now this is the s square plus 8s plus 25. And now I am going to write in another fashion, which is, see carefully, 120 by s is same thing. Here s square plus 8 I can write here 2 into s into 4. So 2 into s into 4, which is again plus 25 I can write in terms of 4 square plus 9. 4 square is 16 and 9 is nothing but 3 square. So simply what I am trying to do is, now I am going to do in this manner also. So therefore this is nothing but s square plus 2s into 4 plus 4 square. It is nothing but a plus b whole square. A is and b is 2. So therefore b is 4. So therefore s square plus 2 into s into 4 plus 4 square plus 3 square means this total will become now s plus 4 whole square plus 3 square. So this is the thing. Finally y of s is nothing but 125 by s into s plus 4 whole square plus 3 square. So this is the y of s. So now I need to do the inverse Laplace transform in order to get the expression y of t I need to get. So now here some of the standard formulas are there. See, sin omega t into u of t, the Laplace transform is omega by s square plus omega square with ROC sigma greater than 0. And similarly, e to the power of minus at into sin omega t into u of t, if you do the Laplace transform here, e to the power of minus at into f of t is nothing but f of s plus a. So wherever s is there, substitute s plus a. So therefore s plus a whole square plus omega square, here omega. Here ROC is greater than the minus real part of a. So if you see carefully, now what I am going to do? See, now I am going to convert this y of s in terms of y of t I need to get. So I am going to assume here a is equal to 4 and omega is equal to 3. So what I am going to get? So e to the power of minus 4t into sin 3t into u of t. Here a is equal to 4 and omega is equal to 3. So wherever omega is there, substitute 3, and wherever a is there, substitute 4. So this is the expression I am going to get. So you see carefully here these two equations. If you see carefully these two equations, s plus 4 whole square plus 3 square, and here you got 25 and here you got 3. So now I want here 25. Here also I need 25, means I need to multiply by 125 by 3. Then only 3 get cancels, then only I am going to get 125. Means I need to multiply these two equations, these two input and these two equations by 125 by 3. So therefore here 125 by 3 you multiply here, and here also 125 by 3. So 3 get cancels. So this you are going to get 125 by s plus 4 whole square plus 3 square. Here same 125 by 3. So this is the equation I am going to get. If you see carefully these two equations here, everything is same except 1 by s, everything we have got. So now somehow we have to do something in order to get this s also, this remaining part s. So there is a standard formula here for x of t. If the Laplace transform is x of s, and if you want to take the integration of this signal, integration from minus infinity to t x of t of d tau, means if you do the integration of the input, the output will be x of s by s. So if you want another term, yes, you have to do the integration of this original signal. So this is the original signal x of t. Let me assume this is x of t. So if you do the integration of this signal, then only we will get what is the Laplace transform we are going to get in this manner. So therefore this y of t, it is nothing but it is the integration of this signal. So if you do the integration of this signal, then only we are going to get its Laplace transform as this one. So therefore this we need to do. Y of t is nothing but integration of this signal. So if you do the integration of this signal, its Laplace transform will be equal to this one. So therefore this is the thing we need to do. So now I need to do the integration of this signal with respect to integration at tau is equal to minus infinity to t x of tau d tau. I am going to assume this as x of t. So therefore in place of t I need to substitute tau. So therefore this is the y of t is equal to integration minus tau is equal to minus infinity to t. Same thing here, in place of t substitute tau. So therefore we are going to get this expression, because this u of tau is going to exist from only tau is equal to 0 to infinity. So therefore this integration is going to converge to tau is equal to 0 to t. And here if you see carefully, this is a scalar quantity, so it is going to come outside. So this I need to do the integration in order to get this response y of t. So here this is nothing but integration of, this is a standard formula here, integration of e to the power of ax into sin bx is nothing but e to the power of ax by a square plus b square a into sin bx minus b cos bx. So by using this formula we are going to do the integration of this signal. So therefore here a is nothing but minus 4 and b is equal to 3. So a is equal to minus 4 and b is equal to 3. So substitute here. Finally we are going to get, this is the thing we are going to get, and we have to keep the limits also. So limits is tau is equal to 0 to t. t. So after substituting tau is equal to t minus of again 0, after doing the rearrangement we are going to get this expression. This is the expression we are going to get after substituting the limits, and I recommend you to substitute these limits carefully and do the simplification you will get here. So now I will do the further simplification. This is the expression y of t. This is the expression finally we have to get. Now I want to do the further simplification. See, there is a minus. So now I am going to take a minus as a common. So therefore, minus I have taken common. Same thing I have written, except minus I have taken as a common. So now you see carefully here, 4 into sin 3t plus 3 into cos 3t. So now I want to make this converse to some sin or cos. So now I am going to take here sin here. So now here this is a 4, right, and this is a 3. So here I am going to assume this is a triangle. So the base is 4 and the opposite side is 3. Base is 4, this is opposite side is 3. So this the hypotenuse will be under root over 3 square plus 4 square is nothing but 5. So now I want to convert this into some sign domain, total expression. So now what I have to do here, the hypotenuse is 5. The hypotenuse is 5. So therefore I have to multiply and divide by 5. So therefore I have multiplied by 5 and also divided by 5. So therefore here 4 by 5 sin 3t and here 3 by 5 cos 3t, here into multiply by 5. So 5 5 is 25. So finally we are going to get minus 25 by 3 into e to the power of minus 4t. Here 4 by 5. 4 by 5 is nothing but cos theta, because adjacent by hypotenuse cos theta, and even thing is same here. 3 by 5, 3 by 5 is nothing but it is a opposite by hypotenuse, which is sin theta. So therefore sin theta into cos 3t plus 5. So now what I am going to do, this is nothing but sin a into cos b plus cos a into sin b. So it is nothing but sin a plus b. So therefore sin of 3t plus theta, one is a and another is b. So therefore, see, now I am going to write in another fashion. This 5 I am going to take it here. 5 minus of 25 by 3 e to the power of minus 40 into sin 3t, sin of 3t plus theta. Theta is nothing but here, see carefully, tan theta is equal to 3 by 4. So therefore theta is equal to tan inverse of 3 by 4. So in place of theta I am going to substitute tan inverse of 3 by 4. So finally this is the y of t response of this system. So here first thing is we have completed, and the second thing is we need to find what is the maximum value of this function. So here y of t, this is the time domain expression, and now we need to find what is the maximum value of this function. So this is the output expression, y of t is equal to 5 minus 25 by 3 e to the power of minus 40 into sin of 3t plus tan inverse of 3 by 4. In the question they also given the input is 2.5 into u of t, means the input is 0 for t less than 0. So therefore we have assumed the system is also linear system and time invariant, and also here we have initial rest. So therefore the output will be also 0 for t less than 0. So therefore this is the only equation for t greater than or equal to 0. So now we need to find what is the maximum value of this function. In order to find the maximum value, we have to do the first derivative is equal to 0. So therefore you have to do the derivation of this signal is equal to 0. So derivation of any constant is 0, and this is minus 25 by 3. Here u into v. So uv whole derivative is equal to u derivative v plus uv derivative. So I am assuming u as e to the power of minus 40 and v as this expression. So first I need to do the derivative of this one. It is nothing but minus 4 into e to the power of minus 40, and same thing plus this is u, again v is, I need to do the differentiation of this one. Sin is nothing but cos, same thing, and inside I have to do differentiation. So 3t is nothing but 3. This is a constant, so it will be 0. So therefore now it is equal to 0. So this is now constant, right? So constant, anything by constant will be 0. So therefore this total has to be equal to 0. This total expression has to be equal to 0. After doing the rearrangement, means I have to take this one to the right side, and then sin by cos is nothing but tan. So therefore tan of 3t plus tan inverse of 3 by 4 is, it is nothing but 3 by 4. So now at what values of t I will get here 3 by 4. If you see carefully, when t is equal to 0, so 3 into 0 is nothing but 0. So tan of tan inverse theta, it is again tan theta, which is tan of tan inverse theta is equal to theta. So therefore 3 by 4 is a theta. So therefore this is a 3 by 4 is equal to 3 by 4. So similarly when t is equal to pi by 3, substitute here pi by 3. So tan of pi plus tan inverse means theta. Suppose tan of pi plus theta is nothing but again tan of pi plus theta is tan theta. So therefore now what we are going to get, tan of pi plus theta is equal to tan theta. Theta is equal to tan inverse of 3 by 4. So finally we are going to get 3 by 4. Similarly, set 2 pi by 3, 3 pi by 3, for 4 pi by 3, for all these values, for 0 pi by 3, 2 pi by 3, 3 pi by 3, 4, 5, again 6, 7, for all those things we are going to get this equation is going to satisfy. So out of this, only for one particular value of t, the function will have a maximum. See, if you see carefully, this is nothing but some constant and there is a exponential decay with respect of sign. So therefore, this is the nature of this one. See, like this, the graph will be, this is a t, right? This is a y of t. So what we are going to get, the response will be final value at t is equal to infinity, this total exponential decay will become 0. So therefore, final we are going to get 5. So therefore, this is a 5, this is a 5, right? So let me assume this is a 5. So the response y of t will be like this one, like this, decaying manner with a sinusoidal shape. So finally we are going to get here 5. So this is the value of this one. So we are going to get peak values. This is at t is equal to 0. And this is the first peak at t is equal to pi by 3. And similarly the second peak at t is equal to pi by 3. And similarly third peak as 3 pi by 3. So like this it goes on. So 0, pi by 3, 2 pi by 3, 3 pi by 3, 4 pi by 3, like it is goes on. And finally at t is equal to infinity we are going to get 5. So if you see carefully, the first peak overshoot is going to occur at t is equal to pi by 3. But at t is equal to pi by 3 we also getting, but it's a down. So therefore it is a lesser value, but we want to find what is the peak value or highest value, means at only t is equal to pi by 3 and remaining all other instance the signal is a decaying, means the peak value goes on decreases and finally it is going to settle at 5 value. So what I am going to say is finally this y of t is going to have a peak value at t is equal to pi by 3, we need to figure out. So in place of y of t, I need to substitute pi by 3. So therefore 5 minus 2 pi by 3 into e to the power of minus 4. In place of t, substitute pi by 3. Again, sine of 3 into pi by 3 and this thing. So I have did the same thing here. In place of t, I substitute pi by 3 and then at t is equal to pi by 3, we are going to get the peak value. So at t is equal to pi by 3, substitute all this value and do the substitution, means and do the simplification. Finally, we are going to get 5.0758. So therefore, at t is equal to pi by 3, we are getting a value which is nothing but 5.0758. So this is the peak value of this function, means at no other instant except at t is equal to pi by 3, no other instant, means remaining all other instants are going to have a smaller value when compared to 5.0758. So therefore final what I am trying to say is nothing but this is the expression y of t for t greater than or equal to 0 and the peak value of this function y of t is nothing but 5.0758 at a value of first peak overshoot, which is at t is equal to pi by 3 and remaining all other instants we are going to get a lesser value because this is a exponential decaying sinusoidal, means finally we are going to get value as 5. So this is all about this question. So by this lecture we have successfully completed the 15 questions which are the previous year UPSC Civil Service questions of the signal systems in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel and don't forget to press the bell icon button. So whenever we upload a new video, the direct notice comes to our mobile. If any improvements needed in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. Thank you so much for watching this lecture. Keep smiling, take care and bye bye.